It's also pretty good to look at the framework as it is now in version 3 and see a lot of the stuff we talked about last time. So let's get started. First of all, this is not going to be a very deep technical talk. I'm really not going to go into lots of code. But the idea is I want to get you guys really pumped about writing really good code. So the idea here is writing code that lasts, or as I usually like to call it, writing code you're not going to hate tomorrow, right? Because we've all been there, right? So let me kick this off by introducing you to someone, and we have to go a little bit back into the past for this. That's a little bit too far into the past. This is Rafael in the early 2000s, right? This guy, dude, this guy was really something else, right? Really good guy. He wrote his own framework, right? He actually expected people to use it. Really good guy. Tests, he didn't even know what they were, right? His methods, 500 lines each. It was really cool. I mean, he really did everything you shouldn't do. Singleton was his middle name. It was really good. Those days, no one cared about code quality. Right? It's like, let's just write something that works. Awesome, right? I mean, for heaven's sakes, we use Perl. We're not really worried about the, good quality there. So this guy was really a mess. And every single time I looked at his code, yeah. That's how I feel every week looking at, code that was written in the past. How many of you feel like this when you see your code? Someone else's code? Right? Or maybe it's not like this, and it's something like this. Right? We've all been there. We all look at other people's code and we're like, what were you thinking? What the hell? No, that's impossible. Right? And then we usually fly one big flag as soon as we see that. We write everything. Right? It's not my code, I'm just going to rewrite it because I can do everything better. And that's pretty much how we face most of the, coding for the past, 15 years. And it's good, but if you go out to any conference out there, if you're a speaker, if you start discussing these things in user groups, the first thing people will always tell you, whenever you talk about writing tests or good code, or being careful of all these things, they're going to tell you the big mantra of everyone who doesn't care about this. Real developers ship stuff. Right? That's the excuse. No, I cannot do that because, real developers, we ship stuff. I don't have time to write tests because I'm shipping it. Right. And okay, but that is true. I mean, if your company is not shipping your product, you're not selling something, you're not making money, you're not getting paid, you're on the street. Right? So we do have to ship stuff. However, shipping stuff is something interesting. This is the Tacoma Narrows Bridge in the US. It was built, it's near Seattle. It was built in 1940 to, gap what they call the Tacoma Narrows, which is this big body of water. Has anyone seen this bridge? Well, you have, because you're from there. Good. So this bridge, it's a real story about shipping, because they shipped it, right? It's there. It was delivered. It was built. People were insane to get it done because they needed to cross this river and get, the U.S. was expanding, the whole thing. 1940, that whole era was really exciting. And they shipped it. They shipped it, they put it up there, and then 4 months later, the story changed a bit. So one beautiful day, it was very windy, and the bridge reacted a little bit different than they expected, right? It got the name Galloping Bridge. I wonder why, right? So this is a true, telltale story of us writing software. You write the software, it's shipped, it's delivered, it looks like it should, it looked like a bridge. And once the user starts coming in, you can't handle all those users. Scalability, bugs, everything starts coming into your code. Yeah. See that? That's your sysops guy right there. Yeah. Awesome. Well, I'm glad to say that, actually it's very sad to say that the only person affected by this was a dog. So your code, if it's not good, kills dogs. Think about that. So shipping, just for shipping, is not enough. you need to find that balance. But how do we find a balance between writing good code and shipping? We still need to deliver, right? We need to find that aspect of it. So for many years, I've been looking at this and going through teams and talking to communities and user groups and all that. And I thought a lot about this. And the one thing I found about code is that code has an expiration date. Right? Every code out there has an expiration date. It's either a long one, it's a short one, but it does have one. And that's good. But it's also what drives us to writing, wanting to rewrite everything. So why do we feel like that when we look at other people's code or our code? First, code perishes. It rots. Over time, if you leave an apple on the table, it'll start getting, more and more interesting. Right? It starts decaying, but okay, that's a bit harsh. But the thing is, code evolves. It keeps going. This is because new things come around, new paradigms, new ideas come, right? The code keeps evolving, new languages come around. I mean, years before, we didn't have, Scala, Go, all these things, Swift. These are all new things, and now you want to rewrite all of that Objective-C in Swift. Yay! But that's it, that's code, it's going. New things are coming, new technologies, new types of databases, new types of storage. So code does evolve, and we need to keep up with it, because if we don't get a job. This is technology, man. We got to keep up with everything. It's very hard because we're all, self-taught engineers who keep reading things every day and trying to work with new technology, and the boss is saying, deliver, right? But we have to find that balance. But not just code, the languages also evolve. I mean, how many of you here are using PHP 5.3 on a daily basis? Anything below 5.3? Yes, good. 5.4? Right? And 5.5. Cool. Who's running 5.6? Oh, come on, it's in pre or release candidate 1, 2, 3 already. Hip-hop, that's a good thing, yeah. So languages evolve, new features come around. I mean, we want to use PHP 5.4 or 5.5 because you have like generators, 5.3 had namespaces. You want to keep up with, you want to use those features, right? A new language version is the equivalent of a Christmas gift under the Christmas tree. You're like, oh, I want that. I want to use it, right? So languages also evolve, and we need to keep up with that. So code does need to be refactored because of that. But even more than that, you evolve. Because you keep learning things. You keep moving forward. You expose yourself to new design patterns, new ideas, new frameworks. All of these things also change who you are. So if you look at your code when it was written in PHP 4, yeah, you're going to cry. That's usual, right? It's PHP 4 code, come on. So all these things, they keep evolving, and you got to keep up with them. You can't stop code, you can't stop language, and we don't want to stop it. We want it to get better. So this is something that we need to prepare for. Another thing that causes you to want to rewrite other people's code is complexity. Because complexity kills comprehension. The minute you open up somebody's code and you don't immediately understand what it does, oh, this guy was crazy, I'm rewriting it. Right? You don't give him 5 minutes, and it's like, no, I don't, rewriting it. Right? So the more complex code is, the more unreadable it is, the more people will want to rewrite it. If you open up someone else's code and you can understand immediately, oh, this is quite clear, it's dry, it's doing exactly what it should, okay, you're not going to touch it. Well, you're still going to want to touch it, but at least you won't be able to justify touching it. Right? So complexity really kills that comprehension. You want to keep that complexity down. You want people to be able to understand your code easily and go through that. The other thing that really kills us when we look back at code is bad design. Right? When you start developing a project, there are certain things that you don't know that you're going to find out later. And then, this happens. Right? So you need to be able to, as a project evolves, you need to be able to keep track of these things and go back and refactor, redesign, because the project is also changing. Right? And bad design is something that you can change it. Right? The one thing that you probably cannot change is the next thing, which is bad specs. Because, clients. Right? How many of you love your clients? Forget the money part. How many of you still love your clients? Oh, that's good. That's good. You actually like your clients. How many of you have clients who change their mind every single day? Oh, okay, that's more like it. Yeah. So, I mean, when we start projects, we have bad specs. And that's inherent in the project. Clients will change their mind. This is expected of them. If they didn't, we wouldn't have a job, because we would have done, 5 years, 10 years ago, we would have been done with all the projects. But now they keep changing their mind. So dealing with bad specs means that your code needs to be able to react faster to these changes. That's why we invented Agile, right? Because we didn't want to find all these changes at the end of a 1-year period. We wanted to figure out these changes, week by week, so we can start adapting to it. And then the final reason that makes everyone want to rewrite everyone else's code is NIH. Does anyone know what NIH is? Exactly. Not invented here, or as we like to call it, the German art of humiliating anything that's not built by them. I'm German, I can make that code, so I can make that joke. So not invented here is intrinsic into our culture, and it's bad. It's really bad. This is one of the things that you really need to fight in your culture. If this is the mentality that your team tackles any project, yeah, it's just a question of time until you fail. Right? You really want to get rid of this, because there's plenty of good people out there writing plenty of good code. There's also plenty bad code. We're going to leave that aside. But there is a lot of good code out there. Right? And this is an example of it. If CakePHP was not good, you wouldn't all be here. Right? So trust in other developers. Evaluate it, of course, make sure that the code is good and not just grab anything and go with it. But make sure you have good things. So I would love to tell you that there is a silver bullet, a big solution. But the reality is there isn't one big solution to this. Right? There isn't like, oh, if you use this tool, everything is fine. The tonic for good code. Maybe we should try and make that. But that isn't. There is no one solution. There are things that you can do to resolve this, not resolve it completely, but at least, diminish it. So, through all this and looking at other people's code and thinking of all this, I have a few ideas which come to mind, and I would like to share them with you. So the main idea for me to improve code, there are a few steps you can take. So the first thing you want to do is you want to make your code easier to comprehend. Right? You want to make it easier for people to understand what you're trying to do and what you accomplished with that code, because they're not always the same. You want to be able to understand that. So that's step number one. You also want to be able to ensure your code is flexible, because you want to be able to react to bad design, to bad specs. You want to be able to change those things and keep going. The other thing you want to do, and there's a bigger reason for this, it's about, 7 feet tall or so, called Chris Harches. You want to write tests for your code. You want to make your code tested, because that's going to give you confidence that the code is actually doing what it should. So you want to make sure that tests are in there. The other thing you want to do is you want to make it easier to replace, refactor it. Refactoring is part of the development process. Don't kid yourself. Refactoring is not a bad thing. Refactoring is a good thing, but you need to spend more time creating new code than refactoring old code. Right? So refactoring is a part of it. And you want your code to accept refactoring better. If refactoring module A means you have to rewrite half your application, you're failing. Now, if refactoring module A means you just touch module A, you're doing a good job, because now you can make that whole module reflect exactly what it is you need, and it doesn't affect the rest of the application. Right? You want your code to be modular, to be able to do that. And finally, the best way to improve your code, and I guarantee this 100%, is you make it not exist. Instant good code. RM/R2. Gone. That's it. No, I'm kidding. But really, the less code you write, the less code you have to maintain, the less code you're putting out there. So if you can reuse something else, it's a lot easier. Right? Cool. So a few things. if you want to get into this and you want to look at a few things to research and think about, first thing is good design. There are plenty of concepts out there. DRY, KISS, do not repeat yourself, keep it simple, stupid, solid, stupid. We're going to go for a few of those. These are all lessons that people have learned over time when writing code. These are all things that people have done, tried, and proved. So read about them, learn about them. They're coming up every day with new ideas, right? The Gang of Four, all of these things. Read them. That's part of your history. It's like our Bible, right? You don't have to agree with everything. Not every design pattern is right for every other situation, but being aware of all these things makes you make better choices. So be sure you know all about these. What are the good ones you want to have? Solid. And I think James is going to talk a little bit more about solid tomorrow. So I'm not going to go into any details anyway. But you want to keep these things, single responsibility. Every piece of code is doing one thing. It's like, can you imagine when you're trying to take care of your kid, write code, and iron the clothes? Does that go well? It doesn't. Yes, and yeah. True. Maybe they should be writing the code then. Right, so, make sure that code also does that. Let code do one thing and do one thing very well. Right? The open and close principle, it's easier for you to, decouple stuff. Liskov substitution, being able to specialize classes so you're using the exact pieces when you want. Same thing with interface segregation, right? The minimum amount of code that needs to be interacted with should be what you're going to use. So these are all principles, right? If you think about this when you're writing code, you will start noticing that code gets a lot easier to manage, a lot easier to replace, to work with, to share. You want to keep these in mind. And I hope James does a great job of explaining all the details to you, which I didn't, but I'm sure he'll do it. Cool. The other thing you want to keep in mind is stupid. Not the guy next to you. Stupid, the acronym. You want to avoid these things like singletons, not being able to test code. Things like, optimizing prematurely. That right there, that is one of the biggest problems out there. People trying to optimize stuff before they actually need it. Right? They might never need it. It's like, oh, I wrote this really cool thing, and the company went bankrupt yesterday. Yeah, cool. So, don't do that. It's good to plan. You want to know that, hey, in a year, I'm going to need this big farm full of 50 computers, and my code needs to scale like this. And cool, so you plan your code in a way that when you get to that point, you can easily get it to what it needs to do. Not optimizing doesn't mean you're not going to think about the future. It just means you don't need to implement the future now. Minimum viable product, right? Get the stuff that needs to be done now, but make sure that stuff is ready for what's coming next. So think about the future. Whenever you're writing code, always think about the future. Don't write code in the now. Write it in the future. And yeah, indescriptive naming is also one of those things you want to avoid. Who saw my Object Calisthenics talk two years ago? Your code sucks. Really? I thought there were more people. Good, you're going to be blown away in a second. I swear. So keep in mind these things. Indescriptive naming is really, really a problem. Because when you make those smart little 2-letter variables and you're like, yeah, TR, haha, awesome. Then someone comes and says, oh, table row? No, translation. Right? We're not one single entity, which is also good given what I saw last night. But we don't share that knowledge. So if you abbreviate stuff, you're thinking everyone understands exactly what you mean. They don't. They usually don't. So don't abbreviate. Use bigger names. We have IDEs that help with autocomplete. Come on. Stop being lazy. So keep in mind these things, right? Keep in mind all of these concepts are stupid, and James will get you more details tomorrow. The other thing you want to know about, design patterns. How many of you here know design patterns? Okay, the rest of you have homework. I mean, seriously, design patterns, You know, they're like stencils. Things, ideas that someone already put code through, and you're like, oh, how can I solve this problem? And they have a little strategy there. Oh, maybe if you do this and that, you know, that's a strategy. Use that. You don't need to reinvent the wheel. Someone already did it. Take different parts of that wheel and make your own cool, awesome, shiny wheel, but don't reinvent the whole thing. You know, inspire yourself from other people's code. Other people's code. I keep eating letters. So design pattern is really something you should look at. We talked a lot about, you know, making code not exist, and we now have a tool for it. It's called Composer. Right? So we just had a Composer talk. How many people here are actually using Composer already? Awesome. At work? Okay, that's good. Good. So Composer is a really good tool to fight against not invented here, because Composer changed the way the PHP developer thinks and works. Composer is, and I can't stress this enough, it is revolutionizing PHP. Thank God we came up with this concept. Also, Git submodules is, I'm not even getting started about SVN externals, right? This is a tool that we needed. This is something that we needed. And this brings along something that's really good, and I like it a lot, and it's Py. It's the opposite of not invented here. It's proudly invented elsewhere, right? And that's really good, because we're now reusing code. We're not writing things anymore. We have all of these small little bite-sized libraries, which are really cool, and you can now drop them into your project. I mean, look at all the different pieces of Cake3 that are already spread out in Composer. That's awesome. All of these things you don't need to solve anymore. You can just drop that code in there. That's really cool. So I like to give a few examples. Unfortunately, I didn't have time to research all the Cake ones. Sorry. But one thing I like a lot is Guzzle. Guzzle is one hell of a little piece of Lego that fits in most of my projects. I do a lot of API interactions, and writing wrappers is a pain. So Guzzle gets me half of the way there. It's really good. Another one is Ardent. So Ardent is a collection. Oh, sorry, I didn't explain Guzzle at all. What am I doing? So Guzzle is like an HTTP client. It's really good if you're writing wrappers for APIs. You basically write a JSON file that describes your API. Things like Swagger generate that automatically. And if you write a few, 2 or 3 classes for Guzzle, it does all of the hard work underneath, and you just give it that JSON file, and it can generate everything you need. But it can interact with that API easy. It's a really, really good, slim HTTP client, especially for talking to APIs. Ardent, on the other hand, is a library of a whole bunch of collections, right? How many of you remember double linked lists, hash, queue, all that stuff from school, right? We all remember that. Horrible. It's really hard to remember all of them. So it has a whole bunch of these, right? And if you saw my talk 2 years ago, you would remember that, you know, using collections is one of the items in there. This really helps with that. So there's also another aspect, which is readability. You want your code to be easy to read and understand, right? You want to be able to look at that code and say, okay, oh, that's exactly what's going on. What was DHH from Ruby caused a big fuss in the internet, saying that we're not engineers, we're code writers. Well, to an extent, he's right. You know, code is like text. You want your code to be easy to read. And one of the things that really makes text easy to read is called paragraphs. Have you ever tried to read text without paragraphs or commas and stuff like that? Otherwise known as Facebook. Right? People just post that big lump of text, you're like, oh, I'm not even going to read that. Paragraphs are really cool, and they also apply to PHP, to code in general. Right? You can break it up in different paragraphs by creating, you know, adding a single line in the middle there. You separate this block from the other block of things that are doing different things, the mind shift within the functions. Oh, I'm now getting entities. I'm now validating them. Right? Break your code up into those logical blocks. Whoever is reading it say, okay, this is just that, that's this. It's easier to understand. And the other thing is white space. We are not JavaScript. We don't care about file size. If you look at the frameworks out there, we really don't care about file size. They're huge, right? But it doesn't make a difference to us. And white space really helps whoever is reading your code. You know, if you put space around the negation marks and all that kind of stuff, if you align your operators, it just makes it so much pleasant to read. And I'm not saying this because, oh, it's really cute, it's like lined up. No. This is like scientifically checked and looked at. It makes it easier for your brain to absorb that. So try some of that. Try adding some white space. So these are some of the things I've been going through, and there was one thing that really changed the way I thought about code, and I shared it at CakeFest a few years ago. But since you're apparently a whole new crowd, I'll share it again. So this comes with a little story. A few years ago, I used to work for the SWAT team. No, not these guys, just these guys. Right? It was a research and development team, half in Cape Town, half in São Paulo. It was a South African company. And in Brazil specifically, we had 3 PHP backend guys specialized in that stuff. That was myself. And you might recognize this guy as Guilherme Blanco from Doctrine. Yeah. Canadians are really happy we sent him there. Oh, Guilherme, so much fun. But Guilherme is one of the writers from Doctrine, and Otávio Ferreira was also the other guy he's genius architect and engineer, like really cool stuff. So the cool thing about being an R&D team is we didn't worry about delivering products, we just worried about theories and thinking and analyzing stuff, right? So we did training and stuff within the company. We didn't have to worry about making money. And that gave us a lot of time to think. And one of the problems we wanted to solve is how can we write code that will last, that new developers can come in and understand and produce code of that same quality and keep it going forward. So we dove into a few books, we gave it a bit of thought, and we ran into something called object calisthenics. All right, so object calisthenics was thought of by Jeff Bay in a book called The Thoughtworks Ontology. And it's amazing. It's pretty cool, right? If you look at it, you have no idea what it means, right? Calisthenics. Does anyone know what calisthenics means? Exercise. Okay, good. So basically that's it. Calisthenics is a series of small little exercises, rhythmic stuff, small things, that you repeat over and over to achieve an overall bigger goal. For example, getting fit, right? When you go to the gym and you do 1, 2, that's calisthenics. Repeating that same small exercise over and over again to help you achieve that bigger goal. If you apply that to coding, it's a small group of rules, not even rules, guidelines, or little exercises that you push yourself to do that will help you achieve overall better code quality and simplicity. Right? And so we found this, we looked at it. It was created originally for Java. So there are some differences because Java and PHP are different. Thank God. Right? So we adapted that to PHP and we started checking out to see if that would work. Right? We had a team that was divided with a few more intermediate developers in South Africa. So we tried that. Let's see how that works internally. And it was really awesome. It really changed the way we thought of code. Right? So it's basically a set originally of 9 rules which you're supposed to stick to. But it's not really about the rules. The thing about calisthenics is that it's about the perception that it gives you. Right? I'm going to go over the rules in a little bit. Unfortunately, of course, I don't have enough time to go over them in the 10-15 minutes I have left, because obviously it's too much. At the end of the slides, there is a link to a recording of a talk I did with the slides and extensive details all over the place of discussions around this. So I invite you to take a look at the recording afterwards. If you want to talk about it, I'm going to be here at the socials and throughout the rest of the conference. But it's not about sticking to those rules. It's not about not breaking the rules ever. No, it's about why you would want to break the rules. Right? The rules are all there to give you the awareness of your code. It's like, oh, well, there's rule number 1, but I'm going to break it. Why? If you understand why you're breaking that rule and why you need to, chances are you're going to either realize, oh, I don't need to do that. I need to separate this and do something different. Right? Or you're going to say, yeah, I don't care, and do it. Hopefully you pick path 1, a lot more useful. But that's it. It wants to teach you. So when you're writing code, instead of having issues in the future, you are already thinking of those issues now. You start understanding like, oh, if I keep going this way, this is what's going to happen, right? So for this, we converted it into 10 rules for PHP that talk all about all this. Sorry. Apparently there's no rule about drinking water. Okay, rule number one level of indentation per method. One level. You know when you indent your code, one level. That's it. That's all you have. And this is quite clear because this is going to help you stick to the S in solid. Single responsibility. If your code starts needing more levels of indentation, chances are you're doing more things than you should, right? So I'm not going to have time to convince you on all of the rules. I usually manage to do that. But that's the idea. You see, all of these rules kind of reflect to like, oh, well, if I'm adding this extra thing, you evaluate. Do I really need to put this here? Is this part of another class? If your code can be written in one level of indentation, you know, chances are you're doing just one thing. If you manage to do more than one thing with one level of indentation, cool. Probably should use your powers for the good, but. So that, that's it, it's a big impact, but it'll change the way you think about it. You'll have more classes, more methods, but you're going to have simpler classes, simpler methods. So instead of having one class with 1,552 lines, you now have 15 files with 100 lines. You have more methods and more spread out code that's easier to maintain. Smaller pieces are easier to replace and shift and change. Rule number 2 is do not ever use else. Okay, no one screamed. That's a good reaction. How many of you think this is nuts? Oh, Chris. I've taught you this before. Even worse, I sent Guilherme to teach you. It's like, yeah. So, this rule was one of the things I looked at the beginning and said, no, no way. This can't be good, right? Hi, I'm Rafael Dohms, and I have not written an else in 3 years. So,
just use code.
Exactly. You figured it out. Let me advance. No, that's not it. Think. Yeah, you got me there. Actually, GoTo will probably work for half of this stuff. Ah, okay. Yeah, I'm gone. No, so think about the code that you write where you use if and else's, right? Chances are you have an if, an else, then an if inside the if, and an else inside the else, and then you start nesting stuff. This is what your code looks like, right? You have decision points. Decision points break into different actions, which may break into different action points. By this line here, you're violating rule number 1 already, so you're already doing something wrong. But that's pretty much where you're going with this. If you take this code and you try to read it, do you know how your brain operates when it's reading this? It operates like a lexer, like a parser, the same thing that reads your code. That's exactly what your brain is doing internally, right? It's looking there and it's trying to keep the states and following the paths, and that's complex. If you're just browsing code, doing a code review, you know, that's a lot more effort you need to put into it. If you remove all the else's, right? If you remove this path and this path and this path, basically you rip out this whole thing on this side, and what you end up with is what every method should have. I like to call it the true path, right? That sounds a lot worse than it should, yeah. It's not like Neo or anything, it's just a path. We can call it the happy path, it's a little bit better. But the thing is, your method, whenever you name your method, let's say you have a method called createPost, what do you expect that method to do? If anyone says anything other than createPost, please, the door. No, I'm sorry. That's what you expect your method to do. It gathers information and creates a post, right? It probably gets that information and does it. But there are scenarios where you might not be able to create that post, right? The post already exists. You don't have all the data isn't valid, right? If you start doing ifs and elses and breaking paths, it's very hard for you to read that line. But if you change, only have ifs, you know what those ifs become? Breakpoints. And then you have something like this. Your code has its true path. It's creating a post. Done. Post created. However, if you look at the ifs, you know exactly where that can go wrong. Validation already exists in a database. Database is not there. All of these little errors, they become a lot easier to understand in your code. What you have in the if, usually, ideally, it's going to be a single return, throwing an exception. It should be simple, it should be small. But it basically means this method is really good at creating posts and identifying the situations where it cannot do it and passing that on to someone else. Single responsibility. Someone else is going to handle that error and solve it, right? So you start to understand why else is not wanted in there? Cool. So rule number 3, wrapping primitives if they contain behavior. In Java, ideally you wrap all primitives because everything is an object, like Ruby. PHP, we haven't gotten that far. Hopefully we can get a little bit further in that direction. But it's just not practical to do that in PHP. Everything is an object in PHP would kill your server in like seconds. So wrapping behavior is a lot better. I have a really good example, but it's not here because we don't have enough time. But the idea is, instead of passing true to a function, you pass an object. For example, if your function is a repaint function, and you pass repaint true. True? And then if you go look at the signature of that function, it actually means if you want to animate while you repaint or not. Right? Instead of passing true, you pass in a new animate object. That animate object knows how to animate, and now your repaint method can say, oh, okay, handle this. Go do it. Right? So all of these simple things, you make it more verbose. You're now passing in an object. And when you start finding that behavior, you have someone to put it in, and your method will not be doing more than one thing because it will be handing everything off to that object you passed. Cool. So rule number 4, only use one arrow per line. This has two sides of it. One, it's confusion. 2, it's Demeter's law. Does anyone know what Demeter's law is? Okay, cool. I'll explain to the rest. Demeter's law basically says that you should, basically not think about what's going on the other classes. You should only worry about the interface you're worrying about. So let's say I do security context get user or get token, and then from the get token I call get user. I'm now implying that I know that there's always going to be a token, and then that token has a user. You're starting to infer things about the friends of friends, right? You don't know, talk to your friends. Leave the friends of the friends to the friends to manage. That's pretty much it. It's like Facebook interpretation of Demeter's law. Right? So this really helps you be aware of that. When you start chaining these things, you can have really big problems in the middle. So what if someone suddenly returns a null? Now you get a PHP fatal error, your application's gone. Right? This does not mean you cannot use fluent interfaces. Fluent interfaces are okay, they're a design pattern. What you might want to do also is break them into lines so they're easier to read, because we're also talking about readability here, right? Rule number 5, as you expected, do not abbreviate. We have gone through this. Please do not abbreviate. If you look at the recording of the Object Calisthenics talk, there's like a whole bunch of examples in there. It's really funny. And it's also very depressing to see what we do with abbreviations. But do not abbreviate. Make sure that everyone who's reading your code has all the information they need, right? Rule number 6, keep your classes small. Keep them tiny. The smaller they are, the easier they are to replace, the easier they are to manage. It's just all win, right? Okay, you get the overhead of having lots of files, lots of classes, but that's usually not going to be your bottleneck. I mean, the database is probably going to blow up before your system can handle loading classes, right? So, but keeping them small really helps with that. You're writing small pieces. It's Lego pieces you're putting all over the place. The smaller that Lego piece is, the more dynamic it is, the easier it is to fit anywhere. Use those building blocks in big build bigger boxes, bigger things. The other thing is limit your instance variables to less than 5. Who knows what an instance variable is? Okay, cool. So an instance variable, you know when you get an object and that object has a property that points to another object? Right? That's an instance variable. You have an instance of something in that variable. So basically what it describes is the dependencies of your class. Your class should not have more than 5 dependencies. Ideally, it should not have more than 2. Because you know when you test a class that has a whole bunch of dependencies and then you start mocking things and you spend half an hour mocking all of those dependencies? That's not testable code, that's just painful. Right? So you're keeping those instance variables down, you start segregating stuff. Instead of this one class having to architect everything, it calls 2 or 3 different mediators. The mediators then handle this or handle the other thing. Or you might be able to break those things apart with event listeners. Instead of actively doing something here, throw an event and let someone else catch it somewhere else in your code. Decouples it. Easier to switch all the different pieces. You see a pattern where I'm going with this? Cool. Rule number 8, use first-class collections. This helps you more with handling data back and forth, sending it between places. Because you always have, oh, well, now I need to filter my list. And then you go and write a query that filters it, or you start doing all these things. Well, if you have data collections, and they have all the filter, map, and all these things, it's easy for you to just take that, merge 2 together, pass it on, do different operations. All of your collection-specific stuff then goes into your collections. And then if you're using Ardent, done. Right? Doctrine also has really good collection objects, which you can get apart from the whole Doctrine thing. So this really helps you with shoveling data back and forth. Rule number 9, use getters and setters. So the original rule says don't use them. But Java has one thing over PHP in this case. It's called accessors. Accessors are basically a way for you to get yourself in between the process of setting a value to a variable and doing operations in there. Right? So if you look at ORMs, they do a bunch of like lazy loading, for example. They give you a proxy object. And if you use some data, it'll then go and load that from the database. You cannot do that with PHP if you don't have getters and setters, because there's no way you can get into that process. In Java you can, so it doesn't make sense to use getters and setters. In this case, it does, so we decided into asking you to use getters and setters. And I have found that if you keep your models to data transfer objects, really simple objects that just have getters and setters, it's just so much easier. You can just grab them, push them to the view, and not worry, for example, that the view is going to trigger a query. Right? Cool. And rule number 10, which we added, document your code. Please, document your code. Doesn't mean you have to do this if decides A or B. No, that's what an if does. That's the definition of if. If A, B, right? But it means you want to make sure that all your methods, they have the proper information about what comes in, what goes out, all that kind of stuff. And that's really good. It's good because that's going to help transfer your mindset as you're doing something to the developer who's reading your code. You really want to make his life easier. And mind you, when I say the developer who's looking at your code, that's you tomorrow. Right? It's like the other guy. No, it's really you. Because a week from now, you're going to look at your code and like, what the hell did I do? Right? So document that. Make sure that these things keep going forward. Make sure that the communication between your team is there. So, Object Calisthenics. It changed the way I think of code. Most of the people that I show Object Calisthenics, they resisted at first, but it changes the way they code. I mean, it really changed the way I look at code and feel about writing it. It really feels a lot simpler, right? So I told you this is not going to be a deep technical talk. I hope you can grasp all of these concepts just with the few examples I gave. Please go look at the recordings. But now it's your turn. I want you to leave here with a mission, right? Well, a whole bunch of them. You pick which ones you can accomplish. First thing I want you to do is improve yourself. Read more. Look at books, Talk to other people. Go to conferences. You're already doing it. Just keep doing it. Local user groups, online, RSC. Make sure you're there. Make sure you're chatting to people. Communication really helps. It's going to get you, exposed to new ideas. After you do that, read lots of code. There is no way you can stand anywhere and say this code sucks or this code is not good if you have not read tons of it. The only way you can get all the information you need to be able to understand what is good code, what is bad code, and what you should and should not be doing is if you expose yourself to all of this. So really, read lots of code. Open GitHub and start going through it. You're going to see really bad stuff. Try not to cry when you see it. But you're also going to see really good stuff that's going to inspire you. I mean, you have a whole bunch of core developers here who have written a beautiful framework. Go read it. Go look at what's happening inside. Don't treat it as a black box. Go into it. Read more code. Expose yourself to more code. Write simpler code. If you can achieve something in 5 lines instead of 10, write it in 5. Make it simple. Make it concise. Make it objective. It should do one thing and one thing very well. And if you do that, it means other people can use your code, which makes I failed. Now, so write simple code. And if you don't know how to get to your simple code, if you're not sure exactly how you're going to get that, try Object Calisthenics. Give it 1 month. If you can't do it at the office because you're tight deadline and all that stuff, fine. Pet projects. How many of you have side projects that you work on at home? Good. The rest of you, find one. It's really good. It's another great way of learning, exposing yourself to more ideas. Try different things. And then if you can't do it for the office, do it for your code at home. Try it for 1 month. Stick to all of the rules. Only violate the rules if you have a very good excuse. I'm not going to be there to judge it, so you're going to tell yourself and see if you can excuse yourself. But try it for 1 month and see if it changes the way you look at code, the way you think of where your code is heading. Try it. I guarantee that it's going to, at the very least, you're going to change your mind about something. Might be about me, but hopefully it's going to be about the code. And use someone else's code. Composer is there, full of libraries. Packages is beaming with libraries. Use other people's code. Don't rewrite the wheel. Don't reinvent the wheel. Or rewrite it for that matter. Doesn't matter. But use someone else's code. Try it, download it, check it out, read it. As you're using it, read it, you're now doing both things. You're exposing yourself to it and you're using it. And after you finish doing that, and you start writing all that simple code, and you get all this cool stuff, share it. Share your code. Write more libraries. Small problems. Small problems, small libraries. You get all of those together, you get cool stuff. Right? You're making someone else's life a lot easier. Because now they don't have to do all that, which you already figured out. So go out there, publish your own libraries. Go out there and contribute to other projects, to frameworks. Go out there and show people that you're really good with code. Thank you. It's not an iPad. I work at Simbin. We're hiring. If you're in the Amsterdam area and you want to check out some new challenges, go talk to me. Please rate me on Joined In. Tell me what this talk was like, if it sucked or not. Hopefully it didn't. And the slides will be at slides.doh.ms. And right after this slide, there's the last one, which has the link to the recording and the slides of the Object Calisthenics talk. If you found the idea cool, you want to know more about it, check this out. This is all the material. There's a link at the bottom here also that has a bundle full of links, including a code sniffer that Guilherme wrote. Try it out. Check it out. So does anyone have any questions?
Could you go back one slide?
Yes, I could. That was easy. Next.
I have a question while avoiding else statements. How do you deal data
Mhm.
to if statement, and you have and
Okay, yeah, I get it. So
when you connect different variables, or and. So
you have to, yeah, you have to start making decisions based on that. He's basically asking what happens when you have, situations where you have variables and you want to check if this and that variable combined with an or and and, how you handle that situation. So that's the thing. Usually when we do ifs and elses, we do, well, if they are, do this. If they're not, do that. 90% of the situations you're going to get, this is what you want, and this means it's broken. Right? Agree with me? 90% of the times when you have an if and else, one condition is good, the other one is what you don't want. Right? In that case, that's where you have a breakpoint. At that point, if you throw an exception, or if you stop processing, or if you do something else, that's fine. So instead of having an if that does, oh, this is good, and then the else that, oh, this is bad, you basically, the if is only checking for the bad scenario. You imply that the right scenario is happening. It becomes implied. It's like, oh, I know this variable is exactly what I expect. If it's not, break. If it is, I just keep going. So that true path of the function is right there. You start seeing, okay, words escape me. I'm supposing that everything that's coming in is exactly what I expect to be coming in. Right? Your method believes that what you gave me is exactly what I want. And then it just checks those points where it can exit and go out.
Dependent while you develop or architect the code, right? It belongs together, It's like
Yeah.
Wait.
Yeah. So is there a question to that? Or cool. Sometimes I don't understand questions. But that's it. I mean, you're not just writing code for what it's supposed to do. You're thinking about the code. You're really going for it. That's what it says. It's architecting against just writing the code. You really want to architect it. You really want to think of the effects. It's like I said, these rules, you can violate them, and that's fine. But if you're violating them, I want you to think of why. Because that's going to give you, well, if I'm violating this, wait, does this code actually violate single responsibility, for example? Do I really need this else? Is it useless? Right? So that's the kind of thing that you start thinking if you start sticking to this. And then you find yourself that you start violating the rules less and less. I still violate them on a daily basis. Every now and then, I have more indentation than I need, but I know exactly why. Sometimes you just need it. Like, for example, in doctrine, there's a piece of code that violates all of this together. But that gives them like insane performance, and it's their hydrator. It's like the unit of work thing. It's like the part where if something is, takes more than 1 second, your application is gone. So there's a real valid reason to do that. Right? What I want you to do is think about that reason. More questions?
Just to follow up, basically if both the if and the else are good scenarios, just different, then you can use the else.
Yeah. If you have a scenario where the if and the else are proper scenarios and you're doing handling, then you start thinking of other things. Should I be handling both of these? Should I be passing this off to someone else? Because then you start getting into the single responsibility, right? So it's like, there you go. It's a valid reason to violate the rule, but if you start thinking about it, you might find other things. So it's all about thinking of the code. Yeah.
The last point about documenting stuff.
Yeah.
I think that the message can be misleading because I don't think that everything should be commented. And if you follow the previous rule, you said you give us an example the if A, B or C. But if your method is called get post, I don't see a point to add a command or to say, okay, it gets post and it gets an ID and it returns post.
Yeah.
So here, the reason why should be, I mean that's what I use, should be, I'm writing the comment, why do I do that? And instead refactor before writing the comment.
So, just to repeat it so the camera can hear. If your code speaks for itself, why do you need to document? And the idea of all these rules is to make your code speak for itself better. So documenting kind of goes on the other end of that. That's exactly what I meant. When I go into more details, you see that there's a big difference between the inline commenting where it doesn't need to be and the doc block commenting, where what you want to do is you want to transfer a mindset. You want to, all of these decisions that you're making as you're writing the code, some of these are really important to whoever is going to read it. So that's the kind of documentation I mean. It's not saying, oh, something that's obvious. That's it. You want your code to speak for yourself, but sometimes your code doesn't speak the same language. So in those cases, you want that documentation to be able to gap that bridge. Not always, can the code say everything that needs to be said. So I agree with you. If it's dumb obvious what you're writing, then remove it, right? But you want to transfer that mindset. You want to make that code sure. And the one thing about doc blocks, at the very least, document what's coming in, what you expect to be coming in, and what you expect to be going out. Most of that would already be in PHP with like type hints and that kind of stuff, but PHP doesn't have type hints for scalar. So do yourself an extra favor, make sure all of that is in. Your IDE will really thank you, and that means you're going to get like a whole bunch better with autocomplete, because I'm getting old, I don't remember everything. And autocomplete is awesome. Yeah.
I just wanted to add that basically code documents what you're doing, and the documentation says why you're doing it.
Yeah, exactly.
It's a different thing.
Yeah.
And the other point about the doc blocks, it's if you use tools like Doxygen or PHP, Documenter, etc., the documentation is not always together with the code. You can have documentation generated somewhere where you don't have the code to actually see.
That's the point I usually make in that talk, so I'm talking about code still, documentation. Using tools like PHP Documenter to generate your docs is also a great way to introduce new developers to your team, whereas documentation is in one place, code is in the other. They should be together because they're going to be there with the PHP docs anyway, but you can also generate that documentation from the PHP docs, so it's a really good tool. Actually, Mike Van Riel from PHP Documenter lives in Amsterdam, and I work constantly with him. And he's one of the guys that really inspired me to add this rule and make sure that we write good code so that this documentation is present, because it is really important to other developers to have that documentation. Right? How am I doing on time? Good. Well, if anyone wants to ask any more questions, wants to talk about this, I'm going to be at a conference for the rest of today and tomorrow. So yeah, come up to me, ask questions. Thank you very much.